Bismillah ar-Rahman ar-Rahim. We'll continue doing the problems. What we did in this section until now, 7.2, we have the disk method. The disk method, where we have this strip or this line is right away in the axis of revolution. So we call it the disk method. And then where I have only one region or one revolution, let me say. Okay. So where this one is right away in the axis of revolution. Okay. And now also we have it with respect to y, where I will do the same thing. And then we talk about the washer method. Then we reach the washer method. This is called the washer method, where I have, this line, I have outer radius and inner radius. Where I have outer radius and inner radius. And I think we did these two, for these three problems. Let me continue. Now let me go to this problem. Find the volume of the solid obtained by rotating the region in example 5. This region, the same region, y equal x square, y equal x square, this one y equal x square, and I have y equal x. Okay, but I want the rotation about the line y equal 2. You know, this is 1, huh? So I want the rotation is about the line y equal to, this is my rotation line. This is my axis of revolution. 2. Okay, now be careful about r of x, small r of x, and capital R of x. Yeah, we need to be careful about that. Let me change the color. Okay. Now, what will happen here? Now, when it comes, what will be the capital one? The capital one will be the outer radius. The outer radius, okay, here, in this one, the outer radius is this one, is this from x to 0, like if it is from here to here. This is the outer radius. And the inner radius will be this to 0. Okay? This is the way to think about it. So I have, like, we have two different, two different, or they have something outer, something inner. Okay. Now, in this case, what will be the outer? The outer usually the bigger. Huh? So it will be this one, which is not this one. 2 until this one. And what will be the inner? It will be 2 until this. Okay. But this is this is the region for the line for the region. I have 0 to 1. This is from 0 to 1. So I have the outer. By the way, it's about what? About x, huh? So in terms of x. R of x will be what? As I said, will be this until this one. That will be the outer radius. So it will be 2 minus, what is this function? Minus x squared. That will be capital R of x. What will be small r of x? That will be 2 still, but until this one. Until this. So it will be 2 minus x. Now we'll do the calculation. V, the volume, by 0 to 1, 2 minus x square, minus 2 minus x square, dx. Let me do the calculation. 0 to 1, that will be what? 4 minus 4 x squared plus x to the power 4 is the first one, minus, this is 4 minus 4x, inside the parentheses, plus x squared dx, which is what? By 0 to 1. I have 4 minus 4 gone, minus 4x squared minus x squared. That will be minus 4x squared minus x squared. I have here 4x, so I have 4x minus this with this. Give me minus 5x squared. I have the minus here. Huh? Using the minus plus x to the power 4 dx. That will be the answer. Yeah, now we'll do the integral of this one. That will be what? By 2x squared minus 5x cubed over 3 plus x to the power 5 over 5 from 0 to 1. Okay, that give me what? By 2 minus 5 over 3 plus 1 over 5. Yeah, that give me by 15. I have 30. 15 minus 25. 15 plus 3. So I have what? 5 plus 3, 8. 8 pi over 50. That would be the answer. Find the volume of the solid obtained by taking the region example 5. Still, example 5. The same example, which is y equal x squared. But about what? About the line x equal minus 1. Okay, let us see what will happen. The same region. This is good, since I have the same region. So we notice all the differences. And this is y equal x. Okay, this is 0. And this is 1. Great. But I want it about what? About x equal minus 1. This is will be my axis of revolution. Yeah, x equal minus 1. Okay. Now, if I do the line, it will be what? It should be perpendicular to that. So it will be like this. Okay. And what will be the outer radius? Now be careful. I have y equal x. I need to write everything in terms of x, in terms of y, not in terms of x. I have y equal x. So I make it x equal y, which is nothing. I have y equal x squared, which means x equals square root of y. Since I'm using the positive sign, huh? No need for plus or minus. I'm using the positive sign. Okay. So what will be the outer radius? R of y. It means I need this, this one. So it will be what? It will be square root of y minus 1. Square root of y. This is the right minus the left. Square root of y minus 1. That will be 1 plus the square root of y. What is small r of y, which is this one? It will be, sorry, it will be something like this. So it will be what? It will be y plus 1. Yeah, it will be y plus 1. Okay, so what will be the volume? Will be by, from where to where? Y values. Y values between 0, the same thing. This is 1. I'm talking about the y values from 0 to 1. It's the same in this example, but always it's good to check. So from 0 to 1, r capital RY square minus small r dy. Now we'll do the calculation. Will be by 0 to 1, what I have here, 1 plus 2 square root of y plus y minus, let me do it quickly, minus y squared minus 2y minus 1 dy. 1 cancelled with this. So I have what? Yeah, by times what? 2 square root of y, which is 2 over 3, y to the power 3 over 2. I have y minus y, that means minus y squared over 2. And this is minus y cubed over 3 from 0 to 1. What I will get? By, I have it 4 over 3 minus half minus 1 over 3. That gives me what? 1 minus half, which is half. So the answer is pi over 2. 4 over 3 minus 1 over 3 is 1 minus half. That will be half. So the answer is pi over 2. Okay, this is good. We deal with the same region, huh? But we're doing it. We're doing the revolution about different, rotated about different axes. X-axis, y equal to, which is almost the same as x-axis, but now a little bit different. Now x equal -1. Now it's the other way. Okay, the region bounded by the curve, this and this, is revolved about the x-axis. Okay, so first I need to graph the function, graph the region, I mean. Okay, so this will be my region. This is 1. This is x squared plus 1. Okay. And they have this axis. So let's be the width here. I have this one here. I have the line. The line at x equals 0, it's 3. That will be 3. And the same thing here, 3. I don't care about this, but it will be something like this. Yeah. It will do something like this. This is 3. That will be my line. So for sure, now, the region is about what? About the x-axis. This is my axis of revolution. That will be my axis of revolution. Okay. So I need now the line will be like this. That will be my line, since it's perpendicular to the axis of revolution. Okay. So it means I need this point, this one and this one. So I'll find the points of intersection between the two lines, between the two functions. One is the line, one is the parabola. X squared plus 1 minus x plus 3. Equate them. I have x squared plus x minus 2 equal to 0. So I have x plus 2 times x minus 1 equals 0. So I have x equal minus 2 or x equal 1. So this is 1 and this is minus 2. Yes. Now I know the limits of integration. Okay, what will be the outer radius? The outer radius, because the outer radius will be what? Will be the line. Since I'm doing the revolution about the x-axis. So it will be the line. So it will be minus x plus 3. The inner radius will be the parabola. X squared plus 1. Okay, now the rest is just calculation. What will be the volume? By, yeah, it seems to be complicated calculation. Not complicated, too many, I mean, too much calculation. Minus 3, minus x plus 3 square, minus this one square, dx. Okay. Yeah. Let me see what will happen. That will be by minus 2 to 1. What is this? X squared minus 6x plus 9. Okay. Minus x to the power 4 minus 2x squared minus 1 dx. Okay. So it will be y. Let me do it right away. I have x squared minus 2x squared. That is minus x squared. So it will be minus x cubed over 3. I have minus 6x. That's it. Minus 3x squared. Okay. I have 9 minus 1. That's plus 8x. Minus x to the power 4 minus x to the power 5 over 5. That's from minus 2 to 1. Oh. Okay, let me try to deal with these fractions. That will be by, plug it. I have minus 1 over 3 minus 3 plus 8 minus 1 over 5 minus, yeah, what is this? 2 cubed, 8 minus minus 8 over 3 minus 12 minus 16 plus 32 over 5. Okay, that will be by, let me check, minus 1 over 3 minus 8 over 3, that is minus 3. Okay. This with this, don't forget there is a minus sign here, huh? So I have minus 3 plus 8 plus 12 plus 16. So I took this, everything, huh? Minus 1 over 5, minus 32 over 5, minus 33 over 5. Okay, that will be y times what? Yeah, 8 and 12 is 8 and 12 is 20. 36 minus 6, that is 30 minus 33 over 5. So I have 150 minus 33 over 7. Over 5 by 7. That gives me 1175 over 5. That will be my answer. This is the points of intersection. Okay. The region bounded by the parabola y equal x square, y equal 2x in the first quadrant. To generate a solve, find the volume of that solid. Okay, let me grab the function. As usual, I have y equal x square, y equal x square, and y equal 2x or x, it's okay. So we're talking about this region. Okay. But the revolution about what? Y-axis. So this is my axis of revolution. This is my axis of revolution. So I want the line to be perpendicular to that. So it will be like this. So it means what? I need to deal with y and to write everything in terms of y. So here I have x square root of y. Since I have the positive, I need the negative one. Here I have x y over 2. Okay, so I wrote everything in terms of y. Okay, now I have washer method. It's a washer. Let me write it this time. Since I have two functions. They have what? R of y equal what? The outer, that will be the outer, as a function of y. This will be square root of y. And this one will be the inner, which is y over 2. So I have a square root of y. And small r is y over 2. So what will be the value? What are these? This is 0 and 1. Very clear. 0 and, no, not 1. So I will need to equate them. 2x equal x square. So I have x square minus 2x equals 0. X minus 2 equals 0. So it's x equals 0 or x equal 2. This is 2. No, this is 2 for the x. But for the y, it will be 4. This is 4. So the limits of integration will be in terms of y, not in terms of x. So it will be from 0 to 4. It will be from 0 to 4. So the volume will be by 0 to 4. What is it? It's capital R square minus small r square dy. Okay. That will be what? By easy one. From 0 to 4, y minus 1 over 4 y square dy. That give me what? By y square over 2 minus 1 over 12 y cubed from 0 to 4. Okay. That give me by, okay, 4 square. 4 square is what? 16 over 2. That give me 8 minus 4 cubed. 4 cubed is what? 64. 64 over 12. Yeah, 64 over 12. By 4, this is 3. By 4, this is 16. And that will be by over 3, 24 minus 16, which is 8. 8 pi over 3. That will be the answer. Find the volume of the solid generated by devolving the region bounded by the curves y equal x cube, y equal x. Okay, about the x-axis. Okay. Yeah. As usual, we'll graph the function first. Sometimes they're easier. Y equal x cubed, that is y equal x cubed. And they have y equal x. This is y equal x. Y equal x will be here. Yeah, it's more than 1. Yeah, it's more than the front. When between 0 and 1, x is over x cubed. Okay. So I need to have the region. This is my line. What is the axis of revolution? This is the x-axis. This is the axis of revolution. So this is perpendicular. So I'm dealing with x, which is easy. R of x will be x cubed. Small r of x is x, or the other way. Sorry, it's the other way. This is will be r of x equal x. Let me do it here. So this is the upper, the outer, and this is the inner. So that give me what? And volume is by, yeah, from where to where? From 0 to 1, very clear, from 0 to 1. When I say x equal x cubed, I'm getting x equal 0. Or x equal what? Let me do it. X cubed. Yeah, he said x is positive. X cubed minus x equals 0. So I have x equals 0 minus 1, 1. I don't need this since he says x is what was it. So I have this, I'm talking about this region. Okay. So from 0 to 1. From 0 to 1. This is x cubed. So I have x squared minus x to the power 6 dx. Okay, do the calculation. That would be what? X cubed over 3 minus x to the power 7 over 7. From 0 to 1. That gives me by 1 over 3 minus 1 over 7. That is what? 4 pi over 21. Okay. That will be 4 pi over 21. Okay. Another problem, find the volume solid generated by revolving the region bounded by this, y equal sine and y equal cosine. Okay, yeah, be careful here. Y equal sine, this is sine, between 0 and pi over 4. This will be sine, and this will be cosine. And we are talking about which region? Between 0 and pi over 4. So we're talking about this region. X between 0 and pi over 4. This is 0 up to pi over 4. Okay. But I know sine is equal to cosine. So I'm talking about this region. And they wanted about what? About the line y equal minus 1. This is y equal minus 1. So I want something perpendicular, so I have this one. This is my line. So R of y, R of y will be what in this case? It will be cosine plus 1. Huh? So it's like this one. Huh? So it will be cosine ups. Yeah. This is the line. So it will be cosine plus 1. Cosine x plus 1. What is small r of x? Now the other one, the inner, it is sine x plus 1. Okay. So it will be V, the volume will be pi from 0 to pi over 4, 0 to pi over 4, of the outer square minus the inner square. Let's write it 1 plus cosine x better. Because this is not, is the argument is the angle is x only. Dx. Do the calculation. That will be by from 0 to 4. 1 plus 2 cosine x plus cosine square minus 1 minus 2 sine x minus sine square dx. Okay. So I have what? By from 0 to pi over 4, not 4. I started with pi over 4, then it comes over 4. So pi over 4, what? Have 1 minus 1 cancelled. You have 2 cosine x minus sine x. So you have 2 cosine x minus 2 sine x plus cosine square minus sine square. What is this? Cosine double angle dx. Let's do the calculation. We have by, let's do the integral now. I have what? 2 sine x plus 2 cosine x plus half sine 2x from 0 to pi over 4 of this one. So I have by 2 square root of 2. Okay. Two sine x, no, it's, yeah, it's 2 square root of 2 over 2. So I have square root of 2. Square root of 2. So this is what I mean by 2 square root of 2. It's okay. Sine pi over 2. This is 1 plus half minus sine 0 is 0 minus 2. And cosine 0 is 0. So it's minus 2. So the answer is by 2 root 2 half minus 2, which is minus 3 over 2. And that will be the answer. Okay. Do more problems. Okay. Now you want me to set up integral, not to do it, only make a setup for the calculation. Okay. For the volume. Generate by involving the curves about the y-axis. Huh? Okay. So let me graph the functions and be careful. Y equal x square. And this is the parabola to the right. Y square is equal to x. Okay. 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 About what? Y-axis. This is my axis of motion. So I want this. I want this. Okay. Be careful. Or everything in terms of y, not in terms of x. So here, I want everything in terms of y, not in terms of x. So I have here x square root of y, and here I have x y square over 2. Okay. The outer radius, which one to the right, it will be this one, square root of y. The inner radius, it will be y square over 2. Since I have the axis of revolution is the y-axis minus. Okay. So the volume will be by, yeah, from where to where? I'm talking about the y values. So the intersection point, I have square root of y equal y square over 2. So I have 2 square root of y equal y square, square it. I have 4y equal y to the power 4. So I have y to the power 4 minus 4y is equal to 0. So I have y cubed minus 4 equal to 0. So I have y equals 0 or y equal cube root of 4. Okay. So these are the y values. This is as a y value, this is cube root of 4. And this is 0. So the integral from 0 to cube root of 4 ry square minus small ry square dy. That will be by, I don't need to do the calculations, y minus 1 over 4 y to the power 4 dy, which is this one. Correct. Okay. To do this one, set up the integral, do not evaluate y equal x squared, but about x equal 4. The same problem, but about x equal 4. So I have the same graph to start with. Let me do the graph. I have the same graph, which is y equal x squared. This is y equal x squared, and this is the another parabola, which is this one. Okay. And they know the point of intersection and know everything. Okay. And they want it about x equal 4. This is x equal 4. Somewhere. Yeah. Yeah, somewhere here. Is x equal 4. Okay. So this will be the line. But be careful. What will be capital R of y? In this case, it will be 4 minus the outer, which is this is the outer. So it will be 4 minus y squared over 2. As I did before, x equals square root of y. Here, x equal y squared over 2. So it will be, this will be the outer. Like I'm dealing with this, huh? All of this up to here. This will be the outer radius. Since this is the axis of revolution, this is my axis of revolution. So it will be 4 minus y squared over 2. What will be the small r? It will be 4 minus square root of y. Okay. The volume, it's the y values, huh? The same thing. We did the point of intersection before. So it will be 0 cube root of 3, cube root of 4, cube root of 4, the outer square minus the inner square dy. And that is the answer. Okay. Now we'll move to the third part of this section, which is if the base is not a disk, if the base is any, if you have cross section of the base is not with the disk method. Let me read what we have here. We can find the volume of a circular cross section. All of this, we are dealing with the disk. Remember when we started? We started with the disk. This is as a disk. So I have a circular cross section. Okay, now we'll expand that idea to have, we have generalized to solid of any shape, as long as you know a formula for the area of this shape, of this cross section. Some common cross sections: squares, rectangles, triangles, semicircles, and trapezoid. Okay. Well, I need to find the area of that cross section or of that solid. For cross sections of area taking perpendicular to the x-axis, all of them should be perpendicular to the x-axis or perpendicular to the y-axis. Perpendicular to the x-axis, I have everything in terms of x. I need to find the area of that shape. And then for the y-axis, I make it in terms of y. And C and D in terms of y. Huh? I have y between C and D. Here I have x between A and B. Okay. What is the idea? The same like what we did, but now I need to find the area. A of x is the area of the moving cross-section obtained by slicing through x perpendicular to the x-axis. Sketch the solid. Find the formula for the area is square, semicircle, triangles, and find the typical. Find the area of this typical cross-section. Find the limit of integration. Do the integral. So, for example, I have a square. Like in this case, I'm doing it to the cross-section perpendicular to the y-axis, a square here. Here, yeah. So every time we have a different cross-section. Before we have only circle, now we have different cross-section. Okay. Find the volume of the solid shown in figure. This figure. The base of the solid is the region bounded by the lines, and they want the cross-section perpendicular to the x-axis. So everything is in terms of x. Here, in this case, is equatorial triangles. So I have equatorial triangles. I know the area for the equatorial triangles. Square root 3/4 x squared, where x is the base. Where x is the base. You need to know this. This is the area for equatorial triangles. Okay. Now the base of the solid, if we graph it, you have what? Let me graph using the red one. I have two lines here. Okay. 1 minus x/2. How to graph that? 1 minus x/2. So I have at 0, it's 1. At 0, x equals 0, it's 1. At x equal 2, it's 0. So something like this. This is 2, this is 1. This is the first line. The second line is what? Minus 1 plus x/2. So at x, it's minus 1. At x is minus 1. At x equals 0, it's minus 1. And x equal 2, it's 0. So something like this. So I want the base. The base is the region bounded by the two lines. So this will be my base. Okay. I need the base, which this one is square root 3/4. The base is square. So this is my base. This is my base. So what will be the base? It will be the first line, 1 minus x/2, minus the second line. And that give me what? 2 minus x. Okay. So what will be the area? The area will be square root 3/4, the base square. 2 minus x square. And that give me what? Square root 3/4, 4 minus 4x plus x square. That give me what? Square root of 3 minus square root of 3x plus square root 3/4 x square. Okay, so what is the volume? Will be this area, the integral of this area. You know what? Yeah, I can have square root 3/4 as a common factor. The remaining is 4 minus 4x plus x squared dx. From where to where? This is the x. The x values goes from where to where? From 0 to 2. From 0 to 2. The integral from 0 to 2. From 0 to 2. So that gives me square root 3/4. Now just the calculation. 4x minus 2x squared plus x cubed over 3 from 0 to 2. Yeah, let me do the calculation. Square root 3/4. What I have? 8 minus 8 plus 8/3. So it give me what? 2 square root 3 over 3. Okay. Another one. Prove that the volume of the pyramid with a square base, huh? The base is square. Yeah, I need to do some calculations here. What will be the area? Yeah. A square base is this, where h is the height of the pyramid and capital B is the area of the base. Okay, this is capital B, the area of the base, which is, if this is B, then capital B is B square, since you have a square base. Okay. And they have what? This is will be H. Yeah, this reflection will explain everything. Yeah, I have H, which is the height of the pyramid. Okay. And I took the square in the side of, yeah, Y, huh? In the place where I have Y, this is Y. So this is H minus, this is Y, this is H minus Y. Okay, and this is B prime, B prime. I need to find B prime. The base, the area, will be the base, which is base square. Because they have square. I know what's the area of the square. Just on the side square. That will be B prime square. Now we need to find B prime. Need to find B prime. Okay. I'll use this to find B prime. So I have what I have here using triangles. Using the triangles, you have what? Half B prime over half B equals this over this. Huh? I have this is the bigger triangle, this is a small triangle, equal H minus Y over H. So B prime equal to what? B prime will be H minus Y over Y times B. Okay. So plug it here. So that will be H minus Y over Y B square. Okay. Don't forget I'm doing it in terms of Y, huh? This is will be the Y, huh? I'm doing it in terms of the Y values. Of the Y, huh? In terms of the Y. I mean, cross section is perpendicular, yeah, to the Y axis. Okay, perpendicular to the Y axis. So everything I'm doing it in terms of Y, huh? The square here, this one I'm doing it in terms of dx, since I have this perpendicular to the x-axis. These triangles are perpendicular to the x-axis. Here, I'm doing it perpendicular to the y-axis. So I'm doing the calculation in terms of y. Okay. So what will be the integral? V will be, yeah, from where to where? From 0 to h. It will be all the way from until up. So it's from 0 to h. This is, which is b square over h square. These are fixed values, h minus y square dy. So I have b square over h square from 0 to h of what? This is open it, h square minus 2hy. I'm doing the integral in terms of y. So that give me what? B square over h square of what? H cube, h square x, huh? H square y. H square is just a value, huh? Just a value. Minus. Now h is just the value, the integral of 2y, which is y square plus y cubed over 3. This is from 0 to h. That give me what? B square over h square. Substitute, that will be h cubed minus h cubed plus h cubed over 3. This is cancelled. So I have what? 1 over 3 h b square. And what is b square? Capital B. I know the area of the base is capital B. So this will be the volume, which is this one. Okay, let me go. This is a little bit complicated since it's about solid, huh? I mean, a fixed solid. Okay. Now let me do this one now. Okay. Now, show that the volume of the sphere, I have the sphere, this is the sphere. I make a solid disk, huh? or this one, circular. Now, this is perpendicular to the x-axis, so everything in terms of x. So I need this radius, this y. So this is a circle, and I have x squared plus y squared equal r squared. It means y will be, I'm using the positive side, that will be square root r squared minus x squared. That will be my y. So what will be the area? It will be by r squared, by y squared in this case, by y squared, which is the radius. This is the radius. When I put the solid this way, that will be by r squared minus x squared. And the volume from where to where? From minus r to r of this area, which is by, I'm doing it from minus r to r, all the way. So this, it will be all the way, it will go like that. Okay. By r squared minus x squared dx. Let me do the calculation. Or, I know this is r squared, just the value, so this is an even function. So it will be 2 by, from 0 to r squared minus x squared dx. So that will be 2 by, that will make it easier, r squared x minus x cubed over 3, from 0 to r. That give me 2 by times what? R cubed minus r cubed over 3, which is 2 by times 2r cubed over 3, which is 4 over 3 by r cubed, which is this one. Okay. Now we'll talk about pyramid. Yeah. Pyramid, 3 meter high. It's 3 meter high. Okay, this is 3. Has a square base. That's 3 meter in a side. Okay, I want the base is a square. This is a square. Okay. The base is a square. The cross section perpendicular to the x-axis. This is perpendicular to the x-axis. I have, this is the cross section. From the base is a square, x meter in a side. So what will be the area of the square? Since this is x and x, that will be x squared. Okay. And I want the values of x from where to where? From 0 to 3. From 0 to 3. So I have the volume from 0 to 3, x squared dx. That's it. Since I'm using a square, huh? This is the square x. This is the value x. Okay. So I have x cubed over 3 from 0 to 3. That give me 27, 9. That give me 9 meter cubed. That will be the volume. Okay. Shows the solid with circular base of radius 1. Okay. Parallel cross section perpendicular to the base triangles. Huh? I want the one to the base is triangle. Equatorial triangle. We know the area of the triangles is what? The area square root 3 over 4, the base square. Okay. The base square, which is like this. I have triangles here. I have triangles all the way. This is y. The circle will be radius 1. So my circle is x squared plus y squared is equal to 1. This will be my circle. Okay. So what will be y? Since it's perpendicular to the x-axis, I will deal in x. Huh? So y will be square root 1 minus x squared. Be careful here. This is y. But my base, this red one, is 2y. So I have the base, which is 2y, is equal to square root 1 minus x squared. So this is y. This is y. Okay. And I have 2y. This and this. Okay. So what will be the area? Square root 3 over 4. The base square. And that will be square root 3 over 4. 1 minus x squared. That will be square root of 3, 1 minus x squared. What will be the volume? Yeah, from where to where? I want the x values from here, 1, from minus 1 to 1. The volume from minus 1 to 1. Let's write square root of 3 outside, 1 minus x squared dx. It will be square root of 3 x minus x cubed over 3 from minus 1 to 1. Okay, that give me what? You know what? You can make it double, but it's okay. Easy one. That will be 1 minus 1 over 3 minus 1 plus 1 over 3. That gives me square root of 3, 2 minus 2 over 3. Okay, which gave me 4 square root 3 over 3. Okay. Now let us do the same idea, but now instead of we have a solid, which is sometimes you have a solid, it's yeah, sphere or pyramid, or that will make it a little bit complicated. Now, let me do the same thing by revolving the volume of the cross sections are squares or okay. But I have the base is bounded by a function. And the x-axis from this to this. So what will happen here? I have, be careful now. Okay, now I need to graph the function. Okay, this is the graph of the function. Y equals square root 1 minus x, which is what? X should be what? Less than or equal to 1. So it's 1 going this direction. That will be square root 1 minus x. Okay, and I want it on the x-axis. This is the x-axis from x equals 0, from x equal 1. I'm talking about this. This is my base. This is the base. Okay, so I have the line. Huh? If I do the line, yeah. Let me do the line like what we did before. That will be my line. That will be my line. What is the length of this line? It will be the function, which is the base. The function minus 0. So it will be square root 1 minus x. Wait a minute. Wait a minute. Wait a minute. Wait a minute. Yeah. Be careful. The cross sections perpendicular to what? To the x-axis. Perpendicular to the x-axis. Yes, yes, yes. That's correct. That will be the cross section. So the base will be square root 1 minus x minus 0. Okay. So what I have squares. What is the area of the square? It will be the area will be y square, which is square root 1 minus x square, and that is 1 minus x. And what will be the volume? From 0 to 1, x values. Huh? 0 to 1 of what? Of 1 minus x dx. That give me what? X minus x squared over 2 from 0 to 1. That give me 1 minus half, which is half. That's it. Okay. Now have the cross sections are perpendicular to the y-axis. Are perpendicular to the y-axis. And I need equatorial triangles. Don't forget. What is the area of the square root 3 over 4? X squared, where x is the base. This is the base, bounded by this. So I grab the function. Yeah, the same function, which is this. Talking about this. So the base, but be careful here. I want it to be perpendicular to the y-axis. So I'm talking about this. Okay. So I need the function in terms of x, in terms of y. So this one, I have y equals square root 1 minus x, square it. So I have y squared equal 1 minus x. So x equal 1 minus y squared. This is what I'm looking for. Should be in terms of y, not in terms of x. So the base is x, no, 1 minus y squared. The area will be square root of 3 over 4 times the base square. That will be square root 3 over 4, 1 minus y squared square. What is the volume? The volume, I need to think of it in terms of y. That will be from 0. This is still 1. Okay, so from 0 to 1 in terms of y. I have square root 3 over 4. Let me take it out. Common factor. I have 1 minus 2 y squared plus y to the power 4 dy. Now let me do the calculation. That will be square root 3 over 4 y minus 2y cubed over 3 plus y to the power 5 over 5 from 0 to 1. Okay, that will be square root 3 over 4, 1 minus 2 over 3 plus 1 over 5. 15, I have 15 minus 10 plus 3. That give me what? 15 minus 10 is 5, 8. That will be 2 square root of 3 over 15. That will be the answer. Last one, then I will stop. Now the solid, but now have what? It's my circle. The base is my circle. Okay. The base is my circle. The base of the solid is bounded by this. What I have is my circle now. Okay. Okay. From 0 to 1. Same thing. 1 minus square. I have what? Okay. Perpendicular to the y-axis are my circles. Okay. This is only the same. This one. Perpendicular to the y-axis. To the y-axis. So this is will be, yeah. This will be the base. Okay. What is the volume? What is the area for this semicircle? It's pi over 2 x square. It's pi over 2 x square. So what is my base? We did it before. It's 1 minus y square. It's 1 minus y square. This is the base. This is the x. So you have the volume will be pi over 2, 0 to 1, the base square times of y. Since it's perpendicular to the y-axis. Okay, so that will be pi over 2. Let me do the calculation again. I did it. That will be y minus 2y cubed over 3 from 0 to 1. That'll give me what? Pi over 2 times 1 minus 2 over 3 plus 1 over 5. That will be pi over 2 over 15. 15 minus 10 plus 3. That will be pi over 2 times what? 15 minus 10, 8. 8 over 15. That give me 4 pi over 15. Yeah. Be careful. Be careful. Be careful. Be careful. Yeah, I did it this way just to make you notice one thing. And it's my circle, so this is 2r. No, this is not the base. This is not the base. Why? Because I'm doing this for my circles. Okay, so this base, which is 1 minus y squared, is 2 times the radius. This is not the base. This is the function. 1 minus y squared is equal to r. I need r. This is r squared. So we need to be careful and have my circle. That will be r squared. So r will be what? Will be 1 minus y squared over 2. That will be r. We need to be careful. It's my circle. It means your base will have the full. I mean, when you do, I don't have a picture, but when you do my circles, it means this function or this line is 2 times the radius. And I'm looking for the radius. I'm looking for the radius. Okay. Now, so I have what? This is always the my circles. This line will be 2r. So r will be 1 minus y squared over 2. Now I'll do the volume. See what will happen. I have pi over 2 integral from 0 to 1. 1 minus y squared square. Yeah. And I made it intentionally so that you notice this is, because this is one of the usual mistakes. This is my circle. This line, the length of this line is 2r, since it's the full the diameter. It will give you the diameter. So I want what? I want only which is 2r. So I need only r to find the area. So this is give me what? Pi over 2 times what? Yeah, I have square. That will be times 1 over 4 outside. Integral from 0 to 1. 1 minus 2y plus y squared dy. That give me pi over 8 times what? Y minus y squared. Y minus, what is this? No, this is 2y squared, sorry. And this is y to the power 4. I did it before. Okay. So this is 2y cubed over 3 plus y to the power 5 over 5 from 0 to 1. That will be pi over 8. 1 minus 2 over 3 plus 1 over 5. That give me pi over 8. Now I have what? 15. That will be 15 minus 10 plus 3. That give me what? 15 minus 10 for 8. That will be pi over 15, which is the correct answer, which is this one. So just to remind you, what we did. Now, if I need to have different cross sections, and I try to do it with different cross sections. Let me do the one with the, yeah, with okay. Yeah, with this function. I did it with the function, now perpendicular to the x-axis, so I did just with the x values. Squares, خلاص, what is the area? Y square, very easy. The line, this is the base, square. Nothing with the square. Equatorial triangle, the same thing. This is the base, don't forget, this is the area for the equatorial triangle. Semicircles, be careful. This one is the diameter. So I'll give you 2r, and I'm looking for r to find the area. I'm looking for r square, so I'm looking for r. So do the calculation, now the same thing. So I think this is, we did the squares, equatorial triangle. Yeah, semicircles, okay. Okay, this is square. Yeah, I think we did good number of questions. I will stop here. We'll do a summary, then I will do, after the summary, I will go back to what we did, then we'll do all the exams. Okay, I hope it's clear. Let me stop the recording. Yeah. Thank you.